Thanks as well. So, welcome to a talk titled Using the Qt Scene Graph from C++ with QSkinny. My name is Peter Hartmann. Now, this title is very long and very technical. What is the Qt Scene Graph, and what is QSkinny, and what is C++? Okay, well, C++ I hope you know. Who of you has heard of the Qt Scene Graph? That's only very few. So I hope we can answer the questions, what these mean, and then, of course, what QSkinny does and why we wrote it in the first place, and why you might want to be interested in that as well. Just quickly before we start, a few things about myself. Who am I? My name is Peter Hartmann. I started in 2008 working for a company called Trolltech. I'm not sure if you have heard of Trolltech. There's like 2 original employees that I used to work with. Back in the days, I started as an intern, long time ago. I used to be the maintainer of Qt Network and co-maintainer. I was working for Trolltech, for Nokia, and also as a freelancer. Now I've shifted a bit more to use Qt GUI stuff, GUI and QML and Quick. Yes. I'm on Twitter. If you want to give me feedback, I'm happy to receive any kind of feedback, also after the talk or on Twitter or whenever, LinkedIn. Just write me up. Let me know what you liked, what you didn't like, or what you expect. That's it. So, about this talk. What is it about? In one word, in one sentence, it's about using the Qt graphic stack from C++. Just quick show of hands. How many of you have used QML? Many? Half? A bit more than half. And how many of you have used QWidgets? That's even more. So, that's good. So, it's almost half, even more QWidgets. So, it's interesting. So if you used QWidgets before, you might be interested in using the modern graphic stack from C++ as well. That's what QSkinny enables. Yes, so what I hope you can take away from this talk is maybe you get interested in QSkinny, how to use the graphic stack from C++, also how to use QML, or how to mix and match the both approaches. So they're not mutually exclusive. You can use a bit of QML, a bit of QSkinny, or both of them, or only one of them, anywhere you want. Just to make it explicit, what this talk is not about is any type of bashing about QML. I mean, QML is nice, it works well, it has been used successfully in a whole number of projects, so I think it might come across as, oh, we've written this new replacement and you don't need to use QML at all anymore. That's not what this is about. It's just about a new technology that you can use if you like it, and you can still use QML. It works nicely. One reason why QSkinny was written, which is the C++ library that we're going to introduce later, is the team that was supposed to be using it came from a QWidgets background. And in that case, it would have been a new thing to introduce QML. I mean, QML is very simple. You can get started easily, but still there is a learning curve. So if you choose between C++ or QML, it's always a subjective decision, in my opinion. It depends on what the team knows, how big your project is, how long you're going to support it, all kinds of factors that play into that. So it's never only about the technology. Technology is also about the people who are using it. So maybe for some reasons you want to use QML, which is perfectly fine. Maybe in some cases QSkinny is for you. That really depends on the use case. So, agenda. 4 points. First one is QML under the hood. Well, how do you use QML at all, and what does it do? Like, how do you get from the QML syntax that you write, that half of you know, to the pixels rendered on the screen? We have a little introduction and a little sample. If you're using just QML to write your app, then you don't really care about what's under the hood, but still it might be good to understand what it does and also what other approaches might do. Then the second item is the QML C++ boundary. That's what I try to call it. Maybe you've used QTQuick Controls 1 or QtQuick Controls 2, or written your own controls. Historically speaking, in the beginning of QML, I think the credo was write all your UI code in QML. We might see some examples where you might not want to do that, and then came QtQuick Controls 2, where you use a portion, where you write a portion in C++. So the question is how you manage that, the portion you write in C++, the portion you write in QML. Then, of course, I'm trying to introduce QSkinny. I mean, it's not a marketing talk. It's a free library that we used in some automotive project. Unfortunately, the project that we're using it is not public. Otherwise, I would really like to show you. Maybe towards the end of the year, we can show you what we did with that. But for now, we have some examples that hopefully give you a taste of what it does. And then we have a little short outlook. And I hope you have a lot of questions or discussion points at the end. So anytime, feel free to raise your hand if you want to ask something or comment, or also at the end, I think we have some minutes. So let's start with QML under the hood. How do we go from the QML elements that you write to really the pixels on the screen? This might be a bit small. I'm not sure if you can read it on the back. Not really? Okay. So for those of you who have never used QML, it's like this syntax, this declarative syntax where you declare your elements and nest them, and then you write properties and you bind the properties to other properties. So if one changes, then the other one changes, and so on. We're going to see a little example later. For now, it's this syntax that is easily readable. Then the QML engine that you instantiate at runtime takes that QML and transforms it to elements on the C++ side, on the QtQuick side more precisely. So it creates objects in C++, sort of like in a one-to-one mapping. We'll look into that a bit closer. And QtQuick sits on top of the Qt scene graph. That's the thing that I asked about earlier. So what is the scene graph? It's like directed graph. It's data structure that makes it efficient to use hardware acceleration for your code. If you use widgets, it's using this software backend, so it's always updating almost the whole screen, which is nice enough for desktop. But if you want to use OpenGL and try to parallelize your operations, then you might want to use this Qt scene graph, because then you can have nice animations and shaders and all kinds of hardware accelerated drawing that you might need. And then below the scene graph is OpenGL. Or I think they're working on other backends. There's like a Metal and Vulkan in the works, from all I know. I'm not sure. Should come soon, from all I know. I don't exactly know. But yeah, for now, there's OpenGL, but I think the works is to abstract it away and have different backends. And I think, yeah, Windows Direct, what's it called? DirectX, yes. Thanks, Thiago. So let's look into this, the QtQuick layer. How many of you know QQuick item? Just asking. A few. So, oh, okay, that's many. Do you know a subclass of QQuick item? You can shout it out. QQuick frame buffer. Okay, the experts know their stuff. Well, the thing is, I didn't really know. Here you have some subclasses. The thing is, QQuick item is the parent class of all QQuick classes, and as subclasses you have a QQuick flickable, QQuick rectangle, QQuick mouse area. Now, those of you who have written QML before, you probably recognize the names. If you written a flickable in QML before, then a QQuick flickable gets created by the QML engine in the C++ world, so to speak. Same for a rectangle, same for a mouse area. I think there are a few classes that are public, but most of them are not public because you're supposed to use that through QML. So you don't really write in your user code new QQuick flickable. You just write it in QML, and the QML engine does this for you in the C++ world. Also, they're not public, and I had to look it up. I didn't really know that many subclasses of QQuick item because, it's more like an API for QML rather than a general API that everybody uses. Yeah, so this is a one-to-one mapping, as I said. Elements in QML, we're going to see an example how this plays out then in the real world. Now, more interestingly, if we step one layer down to the scene graph layer, we have a lot of different scene graph nodes. I tried to highlight the ones that I found important in blue. There's a transform node, opacity node, clip node, image node, rectangle node, and a lot more. Again, the QSG node is the main node that you can derive from. We're going to see later how this works out in an example. I think it's not important to know all the details about the scene graph. Just remember to parse this, to display the stuff on the graphics card. There's this graph created, and per each QQuick item or QML item that you write, there's one or several scene graph nodes created. Like for instance, if you instantiate a rectangle in QML, you're going to have this rectangle node. If you're going to set an opacity on your QML object, there's an opacity node created, and so on. Clip means you cut off the element at the bounding rectangle. Image, a texture, like an image. Transform node means you rotate the element or you locate it by X and Y position or you skew it somehow. These are the main ones, and there's a few more that I won't go in detail here. Again, this is maybe a complicated diagram. Just remember there are different types of nodes created for each QQuick item. I hope it gets clearer in a few minutes. Yes, so quick example. This is some sort of hello world-ish QML. Even if you didn't write QML yet, I hope you can somewhat guess what it does. You have two rectangles nested here that you see on the right. That's the example. You have a big rectangle, 200 by 200, red. It's like this rosé because its opacity is set to 0.5, meaning it's semi-transparent. Yeah, and then inside that rectangle, you have another rectangle, the inner rectangle, which is 50 by 50. The clip here is set to true, which doesn't really make that much sense because it's not exceeding its boundaries. It's just to demonstrate later how this works out in a scene graph. And then it's anchored at the bottom right corner of the other rectangle. You see anchors.bottom, parent.bottom, and the color is green. And also, the opacity is inherited in that case, so it's also semi-transparent. Now, what do you think? How many QQuick items are created? 2? Somebody says 3? 5? Okay. Well, I mean, of course, by what I told you now, of course, the answer would be 2, but there's also always a QQuick root item that you can anchor it to. That's part of the QQuick window. That's always there. Let's not go into details there. Every QQuick window that you instantiate, every QML app has this QQuick root item so that you can anchor your stuff to. But for the actually code we wrote, there's of course two QQuick rectangles, one for each rectangle. And I think you can see that the properties, the X and Y properties are sort of translated from the QML world to the QQuick item. It has these member variables, X and Y, width and height, pretty straightforward. The opacity that we set, that's the outer rectangle. The inner rectangle. One thing is here, yes, you see the X and Y, it has resolved the anchors, the anchoring. Because remember, the green one is anchored at the bottom right corner, so it resolved these X and Y properties, calculated the real X and Y coordinates. Width and height. The clip here is also, that's missing, could also have been displayed. Yeah, I guess so far it's pretty straightforward. You write your QML, then the QQuick items get created for you by the QML engine. Now, more interesting now is how does the scene graph look like? That's a bit more complicated. I'll give you time to digest this first before I start talking. So yeah, again, we have like the root node, which is part of the root item, and also this transform node, I guess. So the first two, let's just accept that they are there. Then the code for the rectangles actually starts here with this transform node, which doesn't do anything because the first rectangle is at the coordinates x0 and y0, so you don't need to translate it, and there's no rotation set, so it doesn't do anything, but it's still there, the transform node. Then there was the opacity node. Remember, for the outer rectangle, we set the opacity to 0.5, so it inserts the node. Only if you set the opacity will be a node created. So that's why you can never really tell how many scene graph nodes will be created anyhow. It has one or more. So for the outer rectangle, there's a transform node, opacity node, and the geometry node with 200, height 200, which draws the actual item. So that's 3 scene graph nodes per QQuick item. Same for the inner rectangle. We again have a transform node, which does the translation of the coordinates, sets the coordinates. So that transform node actually does a transform. We set the clip to true. That's when I said it didn't really make sense, but we did it anyhow. So we see here now a clip node is created. Then again, geometry node, which draws the rectangle. So yeah, that was a little introduction to QML under the hood. Again, to repeat myself, QML engine creates the elements in C++, and then the scene graph, while parsing, creates the scene graph node and changes them or deletes them or whatever. So interesting to note here is that for each element that I write in QML, there's a QQuick item created, and each QQuick item is a QObject. So there is some overhead in memory, which might be problematic. I mean, mostly it's not, but might be. And we're going to see in a bit why you might want to need some more fine-grained control in that case. Any questions so far? Yes.
How we know that the little rectangle from here is the children of the bigger one?
Sorry?
How we know that the little rectangle is not the children of the big one?
How do we know that the little rectangle is drawn on top of the big one, or?
Yes.
That's a good question. I think they're just drawn first and this is drawn later. If somebody knows better, please feel free to correct me. Okay. Mike is nodding, so I guess that's how it is. So that's you have those directed structure. So you draw the stuff below first, and then you draw the other stuff on top. So that's what the scene graph takes care of. Okay. Next item in the agenda, QML C++ boundary. Not sure how many of you use QQuick Controls 1 yet. Still, yes. QQuick Controls 1. I don't know when they came out, but my guess is like 7 years ago. I'm not sure. A while ago, and the creator was jumping ahead. Just to remind, this is the diagram again. For each element in QML, we create an element in QQuick. Now, QQuick Controls 1. Let's write everything in QML, which made perfect sense at the time. This is a shorted copy that I took out from the slider control of QQuick Controls 1. You see, again, there's a control, ID. You have a style, which is in a separate QML file, which is loaded depending on which style you actually use. One thing that I found interesting was the tick marks, which is, imagine you have a slider from, let's say, 0 to 100, and you have tick marks every value of 5, so you get 20 or 21 tick marks that you draw. If you have a slider from 0 to 1,000, okay, that's a big component, but then you draw a lot more tick marks. So anyhow, you have a repeater, so for the tick marks, each tick marks, you create a rectangle. And yeah, I said earlier that each rectangle is a QQuick item and therefore a QObject, so might be some overhead involved. Anyhow, QQuick Controls 1 are deprecated by now. They were intended only for the desktop, because for embedded they were a bit too heavy, because one issue with it was everything was written in QML. So there was some overhead, and you couldn't really control that much. If you write it from QML, you cannot really control how you want to draw your stuff. Enter QQuick Controls 2, which was, I think, the replacement of, not exactly the replacement, but the newer technology that came after QQuick Controls 1. You just have a thin layer of QML, and below that you have some code written in C++. Again, this is the same control taken from QQuick Controls 2. You see there's a C++ part that you see in the header. The properties are declared to use it from QML. And then below, you see there's a slider.qml, which uses the t.slider is the stuff from C++, and they use it here. So you try to move as much code as you can from QML to C++ in QQuick Controls 2, which goes into the direction of removing your QML code. You move into C++. Now, of course, one of you might say, okay, well, there's your C++ API right there, right? What about this whole QSkinny? Can't you just use this? Well, not really. The thing is, it's private. See here, private export. QuickQuick control is private. You cannot really use it. I mean, you could use private headers, just include private headers, and the API is not changing, so it's not the end of the world if you still use it. But the problem with QtQuick Controls 2 is that it doesn't really let you hook into the controls. Like, there's no virtual methods which allows you to inherit, for instance, the font or the palette or the locale. It's this closed range of controls that you're supposed to use from QML, which works fine. But as soon as you want to implement your own controls, be it because you need some exotic controls or because the control that you want to use is just not there, might happen, then you still fall back to the place where you have to use QML. So again, then you have the problem. Create all your controls in QML, and then you're back to the problem that QQuick Controls 1 has. Yes, I mean, QQuick Controls 2 offers a lot of controls, so if it satisfies your needs, then you probably should use it. You probably don't want to write all your controls from scratch because it already has the sliders and page indicators and all the stuff. and they're more efficient than QQuick Controls 1. But as I said, you cannot really write your own controls in C++ for the user controls. You have to resort back to QML, which might also be fine. But, well, in my opinion, it creates this barrier that user controls have to be written in QML, which wouldn't have needed to be there, I think. Yes, so what is QSkinny? I'm going to show you a diagram again. Again, I'll let you look at it while I take a little drinking break. So you might have seen a similar version of this diagram before. There was a blog post from me about this. Now I changed it a bit, just to demonstrate that you can mix those two. So QSkinny sits on top of QtQuick, just like QML does, which means you get hardware-accelerated graphics, use QQuick and the scene graph and OpenGL, or maybe another backend in the future. In contrast to QML, QSkinny offers a full C++ API, but it also has the properties and signals and slots, so you can also use it from QML. So you see this here. We have some examples in our code, which is, by the way, here, where some QSkinny controls are written in C++ and are used by QML. So they can be mixed and matched. Of course, in practice, if you use them in a big project, I guess there's things to solve, like who has focus and all kinds of things. But proof of concept that you can mix them is there. In this project that I told you earlier, this automotive project, we just use C++. You don't use any QML engine, so we've written everything in C++, which is one option. Not necessarily. You don't need to use only QSkinny. You can mix them if you want. So they both sit on top of the modern graphics stack, QtQuick and QtSceneGraph. Now here on the right-hand side is the old widgets code that looks actually very similar. You see, you instantiate your push buttons and sliders and everything in C++, very similar to what you do here in Skinny. It's just the code below is very different. The widgets sit on the raster paint engine, which means software rendering, which uses the QPainter API, and which really resolves into calls like draw rectangle, draw line. You can do a bit of animations, but you don't really use the GPU for that. Yes. Just before we look a bit at the API, there were some design goals which make it a bit different from QtQuick Controls. QSkinny is supposed to be lightweight. Of course, QtQuick Controls 2 is also supposed to be lightweight. But one thing that the QML engine does, or QQuick does, it tries to render everything at the beginning of every element, unless it's invisible. But even if it's out of the viewport, if it's still rendered at the very beginning. QSkinny tries to only render when it's needed. And maybe if you have time, I can show you an example how it tries to reuse scene graph nodes. So if one goes out of the viewport, you can insert it at the other end again, and then you don't have to create new ones if you swipe or do something. That was one of the design goals. Another thing was flexible theming. Again, we're going to see later. QSkinny tries to separate the design from the content, so you can switch the design at runtime, and you can even interpolate between values. And the old QStyle API was not really very fit for that. And the last thing is dynamic sizing. I mean, of course, nowadays, Qt is used a lot on embedded, where you have a fixed display size and usually a full-screen window. So why would you need dynamic sizing? Dynamic sizing meaning layouts and also scalable graphics like SVGs. But of course, sometimes you change the brand theme, or sometimes you just have to develop for a different resolution in the end. So it might be interesting to have your code nicely arranged in layouts anyhow. I mean, it might be not, but at least there's the option to if you need to. Yeah, or sometimes you increase the font. There might be need for a different layout. I'm not sure if you develop with widgets, maybe you remember the size policies, which are pretty hard. I mean, I find it hard to wrap my head around that, but once you get into it, I think you can manage. And QSkinny has, again, those similar thing, the size policies, like which, if you resize something, which item is growing, which item is fixed, all this kind of stuff. Again, you can also just hard code your sizes, no problem, but it gives you the options to have dynamic sizing. So again, hello world, sort of. Some little example code. We have a QSK window, which is the equivalent of a QQuick window in a way. We create 3 elements, a layout. The QSK linear box is a layout which orders the items vertically. We have a push button without any style, doesn't look that nice. And we have a text label. We add the item to the window, and then we show it. Yeah, and then out comes this. Not very impressive so far, I guess, but you see it's written in C++. It's very similar to QWidgets code. It's just using the modern graphic stack. Now again, let's look what kind of elements are created on the C++ side. Again, you have the root item, which is always there. You have the linear box, and you have the text label and the push button. So all these 3 items that we instantiated are QQuick items. I mean, they don't derive directly from QQuick item, but there's like a QSkinny control, a QSK control, and all kinds of subcontrols. And QSK control inherits from QQuick item. Yeah, so again, this time the QQuick items are generated by hand. Remember, for QML, they were generated by the QML engine. By parsing your QML, the QQuick items were created. Here you do that explicitly. You set the parent-child ownership to set when the items are deleted. You just write your UI manually in C++. I didn't include the scene graph for this, but it's similar. You have the transform node, the rectangle nodes, or how they're called. Again, I'd rather think we could look at a more interesting example. So this is an example from our repository, in case you want to check it out. Let me start it. Yeah, again, it shows a bit more elements. It's not the most fancy UI ever, but see, you have a slider here, and then you have the bindings at the top. You see the value changes, buttons, nothing too fancy. You have the vector graphics here that grows. You don't want to resize your window, but as I said, maybe you want to use a different theme or a different font. One thing that's interesting is that there's the different styles. I can switch the theme, and it even interpolates the colors. As you've seen, there's a soft change. So this might be like if you need some day and night scheme, if you want to switch, like this. Also, there's different style. So for instance, maybe you notice these handles here are not round anymore. They're like more rectangle-ish that you can switch between. So that's something that might be interesting. This automotive UI has like different brands. It's like the same umbrella company, but different brands. So that's interesting in case you want to use this. Yeah, I mean, QSkinny already contains the controls that you probably would expect for automotive. That's also one difference from QWidgets, because widgets has these traditional desktop things, like also slider push button, but you also have the tree views and stuff, and QSkinny doesn't have a tree view because that probably wouldn't be the first thing that you need on an embedded device. Instead, it has, for instance, the page indicators and controls that you might want to expect in the embedded world. But that said, the controls that are contained in QSkinny are just aligned to the project, because that's, for now, what drives QSkinny. So it might be good in one aspect, but it's not the general purpose thing yet, because if we need one in this automotive project, then we implement it and put it in QSkinny. So that's what drives the development. But hopefully, maybe some more people are interested and we can get more controls. So yeah, there was a little example of the layouting and the scheme and brand change. Back to the presentation. Yeah, another example, speedometers. For now, I need to recompile. Yeah, again, simple speedometers. Remember when I said that for QQuick Controls 1, each of those little tick marks would be a QQuick item and therefore a QObject? That's a lot of overhead if you have a lot of tick marks. I mean, in this example, it probably wouldn't really matter much, but if you have a really technical API with a lot of technical API with a lot of little things and lines, so probably you don't, for each single line that you draw, you don't want to instantiate a QQuick item. That might be a lot. Might very well be that it's not a problem, but good to give the user control. So here we have, in this main pane, we have like only 3 QQuick objects, one for each speedometer, and there's one scene graph node for each, the background, the needle, this little knob here, whatever it's called, tick marks, and also the numbers. And again, let me try to resize. So yeah, the resizing works. It's just updating the scene graph nodes with the information about the new sizes, and then it calculates the positions accordingly. Again, we have the thing about the themes, different colors, and also the branding. Like, well, theme and brand is actually the same. It's just like I tend to think of theme just as different colors and brands in different shapes. You see like the knob in the middle changes. Okay, you can hardly read this. But I mean, I hope you get the point. For each element of a QSkinny control, you can configure it how you want and then change it at runtime, if you so think. You can even change the size. You can see that those get a little longer, those little tick marks. So it's very flexible. Maybe you don't need it, then you don't need to do it at all. Yeah, it's just to give you the option to customize it. Yes. Little outlook, or any questions so far? Yes, please.
Styles are built-in, or you have to define via, say, a style sheet. And so one question regarding on the sides, there is a lot of flickering.
Yeah, well, first question, yeah, for now, there's no default style, so you have to do it yourself. We hope to have one style which looks nice, some materialish style or so at some point, but we don't have it yet. Flickering, I'm not really sure where it's coming from. Let's see. Okay, I might be just a projector actually. Don't really know. Or yeah, the driver. Yeah, so I'm not sure what's causing the little flickering. I mean, the scene graph is redrawn anyhow, so it shouldn't be a problem there. Yeah, just a little outlook. QSkinny is, yeah, it's used in production, as I said, but it needs quite some polishing. There's some controls which are there, some are not, and there's no documentation yet. So really, we hope to get around to write some documentation at some point. For now, you would have to dig in yourself, unfortunately. Feel free to try it out. There are a lot of examples in the code, but I hope we can write the documentation. I think in Qt6 there might be a new styling API coming. People are thinking about it. There's nothing set in stone, but I'm not sure how that's going to look like. Also, QQuick Controls 2, maybe they are being opened up, as in made public. I've read some discussions on the mailing list. That's just me speculating, or let's see what's happening. People are starting to think about Qt6 now. So yeah, maybe Qt6 evolves a bit more in the direction of that you can use more stuff from C++. Let's see. That's just talks are just starting, and also QSkinny. We're hoping to make it a bit more general purpose. We're hoping to show the code, show the project, and maybe people find it interesting. I think we still have quite some time, so I can show you another example. So here you have some cover flow thing. It's just colors, but I hope you get the idea. It's like you flick through this thing. It's just implement via like rectangle with solid color. But of course, you can also do that with the QImage. I didn't get the time to finish this for this presentation. Here, so we have 5 elements visible. And I'm not sure how many know this overlay. You can see that's taken from QtQuick. You can see the scene graph nodes here. Here you have like 5 scene graph nodes, and if I flick, there's still only 5 scene graph nodes. You can see they're rearranged maybe in the end. So I think it contains like 30 elements or so, but there's a constant number of scene graph nodes. Every time a node gets swiped out at one side, let's see I swipe in that direction, to the left, and the one on the left, which is visible, will get reused and put here on the right. That's a little optimization so that we don't need to destroy and create scene graph nodes, we just keep reusing them. So we have a constant number of scene graph nodes. That's maybe excessive, maybe you don't need this always, but it's a nice optimization. We have the same thing in our list view, which is maybe more realistic in a way that you have a list view with a lot of elements, and again, constant number of scene graph nodes. You don't need to create and destroy all the time. So this has, I think, I don't know how many elements this has. I think around 30, this whole. Yep, we have 30. Let's maybe set the number to 3,000. I think they will all have the same color now, but you might get the idea. Yeah, they're all red, okay, because it tries to shift the colors slowly. So now it's going from 0 to 3,000. But anyhow, the point is, still, there's only 5 scene graph nodes, and it just keeps reusing them. Yeah, you see some debug output. They're appended and prepended. So there might be certain situations where you try to optimize everything out of your code, and that's hard to do from QML. Often it's not needed, then you don't need it. Sometimes you need it, and then at least you have control over it. Yeah, I mean, we can also make it, see, 300,000. See whether that works. Yeah. So you have 300,000 element now. It just only asks the ones that are supposed to be displayed. And yeah, the rest is just not rendered. And still we have a constant number of scene graph nodes. And you can do the same with the list view. You have a list view of 1 million elements. You just flick, and you have only the number of scene graph nodes that are visible are created. The rest is not. So that might be handy. Yes, and that was another little example. I think that's about it. I hope we have some more questions. Yeah, that's it. Feel free to give feedback after the talk or LinkedIn, Twitter, wherever. If you like to look at the examples and the slides, they're on GitHub, on my GitHub page. Feel free to check them out. And yeah, feel free to ask questions.
Yeah.
And
any question?
Burkhard has one.
So how does QSkinny compare to, say, compiled QML and to QML on processes without OpenGL acceleration?
So compiled QML, I tried to reproduce this UI that I showed you with the 3 sliders and the car. I think QSkinny was a bit faster. I don't have any numbers for you. But yeah, compiled QML takes away at least the startup time. You still have the memory thing though. If you write everything in QML, then you might have more memory usage, but that's just me speculating there. So I can't show you any numbers. But I think earlier versions of QML had sometimes issues with the startup. So with this compiled QML, it's getting a lot better. I don't have any real numbers to show you for now, but that's the thing about which I remember.
For what I understood, the QSkinny just implements its own widgets and does not take advantage of QtQuick widgets. Is it correct?
Well, it's not using QIQuick Controls. That's true. Correct.
So we can expect that we cannot find all the widgets that we are already implemented inside Qt Controls, or are there?
Sorry?
I know that Qt Controls has many widgets available. Are all of them available also with QSkinny?
No, not all of them. I mean, the common ones, they are push buttons and sliders, but not all of them. I think QQuick Controls got, what is it, a tree view or something recently? Tree view? Yeah, so QSkinny doesn't have that, for instance. So we try to implement the common ones as we go, but there are some in QQuick Controls which are not there in QSkinny yet.
Any other question? Yeah.
Can you mix QSkinny elements with QWidgets? Let's say, for example, you have an existing UI, I want to...
Not really, no. Because QSkinny is, all the controls in QSkinny are subclasses of QQuick item, and QWidgets are completely separate. That is thing which draw in software, so that's not possible. And also QSkinny has creating those scene graph nodes, and for widgets there doesn't exist any scene graph, so it's not possible. It's two completely separate worlds. I can show you the diagram again. Yeah, so they're pretty similar, even though the API is often similar, but the underlying technology is completely different. Thanks.
Questions? No, okay. Maybe not. We're done.
Yep.
Thank you very much.
Thank you.
Thank you.